This is my soldering iron monitor circuit. What I did was I took an STM332U temperature sensor and configured it to operate also as a set point controller. So what it does is it monitors, it sends out the voltage on ADIO 0. And what I did was I tied a resistor divider between ground ADIO 0 and the switched power output. The resistor is it turns out a 1206 resistor sits across the pins really nicely, and the thermistor is a EPCOS 10K negative thermal coefficient thermistor. And so I modified the circuit board, put the parts right on the board, soldered them on the board because my connectors hadn't arrived in time. Okay, so because my connectors didn't show up, I hand wired some wires and resistors onto the board. So you can see here is the main connector. I soldered my fixed resistor right here as a 10K ohm resistor between ground on that end and the wires connected to ADIO 0. I bring it out to one of these little plug pins, and then the other side of the resistor again is ADIO 0, and then the switch power signal comes out here, and I connected, just soldered a wire to it here so that I can plug on the thermistor that's attached to the soldering stand. I had to use hot glue to hold down the wires so they wouldn't pull out. It supports it pretty well. Okay, so what I did was I modified my soldering stand. So you see you can see, well, I should start with the composition here. So I have a screw at the bottom here, which corresponds to this screw right here, that gets terminated into a standoff, which is right here. And then I have a couple of nuts to tighten the screw to the stand so it doesn't rotate. And then I have another nut to tighten the thermocouple and my wire together and make them nice and tight. And then I have a screw coming down from the top to connect them all together. So you can see this wire here comes in contacts with the soldering pencil, and that brings the heat to the hot iron to the screw, which couples to the thermistor here, which changes resistance based on temperature. The resistance goes down with temperature with this thermistor, and then it's wired out to some pins that I can plug onto the STM module. So the stand cover goes on like this, and the pencil comes in like this, and when the soldering iron is running, this area here heats up the wire and couples the heat to the thermocouple so I can measure it. The thermocouple has a limit of 150 degrees C, and I was concerned that I would overheat it, but it turns out that the physical contact is just touch. The resistor wire gauge is small enough, so the thermistor hits about 60 degrees C, which is more than enough to tell me that the soldering iron comes on. And then what I can do is I can connect up the sensor, slide the wires down here, and then it just sits in place like that. So it's all nicely self-contained and works pretty nicely. And then see if you can see this, that the set point is 109. Okay, so because of the way I configured the resistor divider, the fixed resistor is between the analog signal and ground, the analog input and ground, and the variable resistor, the thermistor, is between power and the analog input. At normal room temperature, it's going to be, oh, I just popped in. You can see it. I'm sorry, I had the bottom one here. Just popped in, and it's going to be mid-scale. It's going to be about, for an 8-bit resistor, the scale goes from 0 to 255, and so this is going to sit about 128 at room temperature. As it heats up, the resistance will go down, the voltage will go up, and this number will go up toward 255. So a threshold could be set. Okay, so we have the one soldering stand running, this one over here, and you can see that I've got the temperature is a little bit warmer now, 23.5 degrees, and that the set point is 213. It's almost full scale, so the thermocouple is actually measuring some temperature here, and we'll see what our thermistor, our thermocouple here, is going to say. Okay, so it's something around more than 60 degrees C, and you can see that we're pretty warm here on our thermocouple. Oh, 66, 67. Ooh, we're getting pretty hot there. 70. So that's a good indication of things working. So what we'll do is we're going to turn this one off and let it cool down. We're going to plug this one in from being cold and see if this thing will refresh at a good enough rate. Okay, so it's a little above room temperature, 25, and now it's starting to warm up. Let's see if we'll detect a change in our sensor reading. We got one little change there for the hot one cooling down. Oh yeah. We're at 27, 30. Oh, see, it just changed to 133. So you can see the thermistor tracking and the page is refreshing. And you can see that this one over here is now cooling down. It's at 190. And we haven't seen this other one change temperature yet because we're at 50 degrees C. I would expect it to jump a little bit faster, but maybe we can figure out. Oh, there it goes, 177. Okay. On the right. Keep sliding off here. Oh, here we go, and that 194, getting close to full scale. Okay, I think that's a good demonstration of the soldering iron monitor. Can set thresholds now, indicating the iron's on, and then send alarms if it doesn't cool.